Okay, so today we're going to go over the Pythagorean theorem. We're going to do a whole chapter on trigonometry, and part of it is going to be SOHCAHTOA, and we're going to do sine law and cosine law. But Pythagorean theorem, we don't cover it technically in grade 11, so this is a review of it. Okay, I did a couple of questions on day one. If you guys were here, I did a couple of questions that deal with Pythagorean theorem. So let's define it first, and when can we use it, and let's do some questions about Pythagorean. So in Pythagorean theorem can only be used if you have a right angle triangle. That's the only time you can use Pythagorean. So in a right angle triangle, the sum of the squares of two legs, I'll explain this in a bit. The two sides, so the two legs are the sides that form the right angle, equals the square of the hypotenuse. I'll give you, this doesn't work. Okay, so if you imagine a triangle has three sides, right? Can you empty it? So when you're looking at the right angle triangle here, right, you have three sides. Two of the sides, the two that form the right angle, they're called the legs of the triangle. Okay? And the third side, which is the longest side, is the hypotenuse. It's called the hypotenuse. Now that side is always located across from the 90 degree. Okay? That hypotenuse is always located across from the 90 degree.
And this only applies on a right angle.
Only right angle. Alright? Now, what happens is, if you add the area or the square of the two legs, if you add the square of the two legs, it's gonna always equal to the square of the hypotenuse. Okay, so this is where the formula squared plus b squared equals c squared. And in this case, C is always going to be, I'm going to always call the hypotenuse C, and then we're going to call the legs A and B. Okay? Doesn't matter where is A, where is B, because at the end it's just addition, and with addition it doesn't matter which one is which. But C is very important, that C is your hypotenuse. Okay? So, Pythagorean theorem says the sum of the squares of the leg is equal to the square of the hypotenuse.
Should I write that down somewhere?
I already wrote it right here.
Oh.
So this is exactly what took it to right here, but yeah. The formula is a squared plus b squared equals c squared. Now, this formula, you use it if you're finding c, which is the hypotenuse. Okay? Let's say if I gave you A and C, and I'm asking you to find B, how would that formula look like now?
A plus c squared equals b squared, no?
C squared minus A squared.
That's right. So I leave b squared here. It doesn't matter if you write it either way. So b squared is c squared, and then moving the a squared over, it's going to become minus, because that's the opposite operation. Right? So if you're looking for one of the legs, in this case, if you're looking for B, right, you have to isolate for that B squared. Moving the A squared over, it becomes a minus. Are we okay with this?
That's how the question's asked, if we're, how the.
So the question would be, let's say they give you, let's say if you have this triangle, and they give you that this is 4 and this is 5, and they ask you to find this, right? So let's say this is B, right? And then you have to isolate, you know C, you know A, you're finding B.
The switching over to the other side changed the,
So it was a positive A squared, then it's an invisible positive.
Yeah.
When you move it over, it becomes a minus. It's the opposite operation. Are you guys okay with this? Now, same thing, if let's say you're finding A, you know B and C, it will be A squared equal C squared minus B squared, because you're gonna have to move B squared. So that's the case, if you know A, you're looking for, sorry, you know B and C and you're looking for A. Let's look at an example because it will make sense when we're looking at something. So I have here, in order to use the Pythagorean theorem, you need a right angle triangle and you need 2 sides. Okay? So let's write that down. So to use the Pythagorean you need 2 sides, right angle, should write right angle first, and you're looking for third side. Okay? So you're given 2 sides, it's a right angle, you're looking for the third side. Are we okay with this? So let's look at the example right here. So I have a triangle. I know that it is, what kind of triangle is it? Right angle triangle. And I'm given 2 sides. What are the name of these 2 sides? What do you want to name them? Are they A, B, or C? A, B. So this is A, let's say this is B. It doesn't matter. If you call this B and this A, it doesn't matter. It's going to give you exactly the same thing. Okay? The important one that you can't change is the hypotenuse. This is always C, right? You can, they're calling it X here, it's fine. But this is the always C. This can't be C, and this can't be C. Okay? So the formula says A squared plus B squared equals C squared. All what I have to do is plug in my values into A and B. So A is 3. And then I know that C squared is 34. Am I done? No, I'm not done. Because I didn't find C yet, I found C squared. Right? So to get rid of that squared, what do I do? Square root. So you square, because the opposite of square is square root, so that's going to be the square root of 34 equals C. And it's asking you the question round to 1 decimal place. So when you enter that into the calculator, what do you get? So it's 5.8. It's 5.83. but because it's at 3, I leave the 8 as is. So my answer would be C equals 5. I would like you all to try the calculator and make sure that you know how to enter that square root into the calculator, and you know where to locate that square root. Okay? And if you don't know where it is, just go. I'm gonna